How the electric field, it will also be into the plane. Will convert into plane diagram. Then one more diagram, rough diagram, you can keep it. If the block is, there's a rough horizontal surface. So what are the forces that will be acting? Mg, electrostatic force, Q E naught, then the normal contact N. I think this also needed. So what is N is equal to? Normal reaction N equal to Mg plus Q E naught. Then what direction the friction will act, and there's also magnetic force. So let's get into electric field will be acting into the plane of paper. Let's get into magnetic field. Fleming's left hand rule, B bar V naught. Okay, there's a magnetic force is acting here. Then the friction will also act. Now tell me what can happen. What will happen to the particle now? Friction is a resistive force, dissipative force. So the speed of particle will keep on decrease. So here, what this friction will do, it will produce this magnetic force will provide required centripetal force, and the friction will retard the motion. Very simple analysis what I'm trying to do here now. The magnetic field force will try to provide required centripetal force, and the friction what happen will provide a tangential retardation. So let's write the equation. What can be the path of particle? So first we'll get into the mathematics. So here Q B naught V should be equal to mv square R. Small r, I'll write it. That'll be more meaningful. Speed of the particle at any time. So we are getting one equation of like this. Then tangential retardation. So what is the tangential retardation? F equal to minus mat. So this should be equal to mu n m. At should be equal to dv by dt. So what is the question? The time when the particle will come to rest, time when the particle will hit the center, distance traveled by the particle when it comes to rest. ABC, the time taken. So when it will come to rest, when the speed has become 0. And what is n equal to? We have the value here. So let me first get the if you want this m also, I'll send here. What has to be done now? Limit. At t equals 0, what was the projection of? It was projected with a speed v0, and finally it has come to rest. So I'll finally end up with equation mu I think better let m be there. mv0 by mu mg plus qe0. What is this time taken by the particle to come to rest? Let's find out some quantity so that we can further get into problem. Time taken by the particle to come to rest. Okay, after this, time when the particle come to rest. Okay, first part got over. Okay, we are very happy now. Let's do one thing. time when the particle will come to rest and time when the particle will hit the center. What do you mean by center? Yes, sir, can you show us the path? Yes, the path is what I'm going to bring here. No, all of you make observation. It is going to be a plane spiral. Now, what is the question? What you can ask is like, sir, how come you say that it will come to rest at origin only? There's the primary question everyone should ask here. SS, there's a million word question. Actually, that the data should be given AMV not equal to QB not. Then only it can come to rest at origin. Otherwise, not possible. Center is telling I am choosing electron. So let this be given. Sir, how come it will come to rest at center only? So it's a very simple. I don't want to mess up things. So what is the radius of the circular path? MB naught by QB naught. Let's assume that at any instant of time t. When V0, what will happen to the charge particle? When particle has come to rest, what is the mass of particle? Remain constant. Charge of particle remain constant. The magnetic field strength, it also constant. So if V0, then what should become 0? R should become 0. So therefore, finally, where the particle should come to rest at center. So E should have given this. Otherwise, not possible. It may, if maybe this is equal to condition. So this has to be given. I'm introducing this. Otherwise, it will be meaningless to confirm that it will come to rest at origin. Okay, all of you. This data should be given. Then okay, then we can conclude here. Yes, it will come to rest at the origin. So what is the simplest reason? Because M, Q, B naught, they are the parameters which will remain constant whether the particle is at rest or in motion. So therefore, when the particle has come to rest means the R should be 0. R should be 0 means you should come to rest at center. Hope everyone is able to understand here logically. When V0, then R should be 0. What is R? The radial distance of the particle from the center. So when it has come to rest means it should come to rest at center. I'm trying to give a reason of like this. So it'll be like a plane spiral. What you have to call this. Is it angular momentum of particle conserved? So many things are there. We can angular momentum of particle conserved. No, there's a torque is acting all the time. Because the speed of particle will continuously decrease here, no? So can you show at any instant, any diagram so that we will get some picture? Yes, okay, I'll do one thing. So this will be your force, which will probably require centripetal force, and here the friction will act. And this force will be directed towards center. Okay, the time, I think both are same, no? Time taken by the particle to come to rest and time taken by the particle to reach the center. Center or will write origin. What it should be called again same time, that same time only, that one. No, after this, last one, distance traveled. How we can find out distance traveled? I want most of you know kinematics. We were in better position. Anybody, can you suggest distance traveled?
Velocity into time.
Speed into time. Okay, try. No, okay. Velocity into time. Can you make it? Speed into time.
Speed into time.
Yeah, there's the only thing. Okay, can you work out now? I think it will be a little bit, still will land in trouble. It's asking total path length. There's a problem here. I want your law, kinematics and laws of motion into the picture.
Sir, acceleration would be constantly decreasing now, sir.
So,
So we can use v square minus u square is 2s.
oh God, like you are killing total kinematics. Is it decreasing at a constant rate, velocity? Acceleration is variable. No, variable accelerated motion. How you can apply equations of motion? Okay, yeah?
Yes, sir. Yes.
We should not think like that. Okay, fine. Okay, no. See, you have done variable accelerated motion. Go back, kinematics, variable accelerated motion. Tell me what you do. V dv by ds. V dv by ds. So the retardation. So the next part of the problem will be, we know f equal to minus mat. This is equal to mu n minus m. A tangential, this A tangential, what we can write it as V dv by ds. S is path length. So this will become mu, and n I'll substitute later on, no problem. So this will become ds equal to V dv. At initially, okay, let it be this one, and initial velocity is v naught. Finally, it will come to rest, and the total path length, let me call s. S is not displacement, so let me write here, this is s only, will take it. So this will become mu n m s equal to v square by 2 v naught 0. The value of s is needed, so this will become m v naught square 0. Okay, here also 2 mu n. What is the n we assumed it to be equal to mg plus qe naught. Path length, just write path length of charged particle. Okay, so there are many ways. You have to really go back to all your basics. Even for me also applicable, not only for you, for me also. I should not try to do anything very big research. Angular momentum of particle, not concerned, no? So we'll write it here. Angular momentum of particle. Angular momentum of particle is not conserved. What about kinetic energy? It's also not conserved. Why it is not conserved? Because the tangential force is acting, no? And we know mvr, angular momentum equal to mvr of a particle, and continuously the speed is varying, r is also varying. So therefore, as the net torque is non-zero, no? So even the angular momentum also I can ask you. Okay, so one more we have. Yeah. I'll put it in corner.